Good day, my viewers all over the world. I remain Salumaj, and today we're talking about the subject mathematics. And under mathematics, we'll be talking about the linear graph. The linear graph. Linear graph. You are in science class. I would want you to pay attention to this topic. So, when you hear linear, it's an English word. It means straight. Straight. That's the meaning of what? Linear. So we want to talk about what? Straight graph. And in mathematics, I told us that we play around what? Alphabets and what? Figures. When you are saying figures, you are talking about numbers. 1, 2, either negative integer to positive integer. So under linear graph, you're going to have a linear equation. And I told us while I was explaining or introducing us to equation that we have linear equation, we have simultaneous equation, we have quadratic equation, we have polynomials. And when you say linear equation, it means it has a maximum power of 1. Simultaneous equation, we have two variables. We have x and y to be determined simultaneously, as you want to know their values at the same time by solving for it. The quadratic equation has power that is more than 1. This is linear. Power is 1. But if I put 2 here, it's already a quadratic expression. I think I gave us that you can have something like x squared plus 2x plus 3. This is a quadratic expression. Because the power is reducing from 2 to 1 to constant. So for polynomial, you can have power to be more than 2. We have 3 like this. Like say 2x squared plus 3x plus 4. So this is a polynomial because the power is more than 2. It can be more than 3, it can be 4, it can be 5, it can be 6. Once it's more than 2, that is what a polynomial expression. All these things can be represented using a graph. So that's why I said that if you're in science class, in your physics, where they'll be telling you to draw a graph of maybe pressure against temperature or volume against pressure, anything you are being told to draw, just follow this thing I want to explain. The principle applies to all. If you apply it to this linear graph I want to use, you can also apply it to your physics. And the point will reach whether you can have a straight line, you can have a curve graph where you need to determine the line of best fit. That is physics. So I will still teach us about that. So, but let's follow this, which is what? A line graph. In line graph, you are going to have variations. A direct variation, or it can be an inverse variable. But basically, since it's linear, it's going to be what? A direct variation. If I say, let's say we have x or y is equal to 3x minus 2. Y is equal to 3x minus 2. This is the equation. Y is equal to 3x minus 2. Y is equal to 3x minus 2. Y is equal to 3x minus 2, where the range of values of x, is 2 minus 2 to 1. That is how they will put it. They will tell you to draw the linear graph of this equation. And if you are in GSS2, it's a very good opportunity for you to understand this at your GSS2. If you are in GSS3, very sound for you to know. SS1, SS2 to 3, please pay attention so that you don't make all these little mistakes in your exams. So they say y is equal to x, y is equal to 3x minus 2, where the range of value of x is from what? Minus 2 to 1. They are giving you what? Different values of x. So you need to find the corresponding values of what? Y. How do I mean? You have your y is equal to 3x minus 2. That is the equation. Now, they now say where you have different values of x to be what? Minus 2 to 1. First thing you are supposed to do is to draw a table. See the table I'm going to draw now. You draw a table This is how to solve questions like this. You draw a table. This is your x and this is your y. What are the values of x given? They say x is ranging from -2 to 1. So you say -2. Next to -2 is what? -1, because you are going to what? Positive integer. If you remember when I was teaching us about number line, we talked about what? The positive integer and the negative integer. This is what we call the number line. You can have this like this. This is the midpoint. To this side is positive. To this side is negative. And this point that I put dot is what? Is 0. There is nothing like negative 0 or positive 0. 0 is 0. But to the right side of the 0, you have positive integers. So if I say positive integers, your integer simply means number, positive number, starting from 1 down to infinity. 1, 2, 3, 4, 5, 6. Then if I say negative integer, I mean -1, -2, -3, -4, and so on and so forth. So for here now we have x is equal to -2, because they have given us the values of x that is ranging from -2 to 1. So we have -2, -1, 0, 1. 0 and 1. Don't forget, I said they use the number line tactics to explain this. So you are moving from negative to positive, from -2 to -1, 0. This is your number line, it's going this way. -2, -1, 0, and 1. So, like what we have here now, we want to determine the values of y. And how do we determine the value of y? It's very simple. You already know the values of x. To determine the value of y now, you now say when x is equal to -2, what will be the value of y? Then you now go to the equation that you are given. The equation you are given is what? Y is equal to 3x minus 2. So we now have y is equal to 3 into bracket. What is our x? When x is equal to what? -2. That is -2. -2. So we have y is equal to 3 times 2. That is -6. -2. -6 minus 2 is what? -8. So we have -8 to be here. Now, so okay, when x is equal to -1, when x is equal to -1, when x is equal to -1, what's the expression? Y is equal to what? 3x minus 2. So it becomes y is equal to 3 to bracket -1 minus 2. So y is equal to what? -3 minus 2. Y is equal to what? -5. So this is what? -5. Now, so when x is equal to 0, what will be y? So what's the expression? Y is equal to 3x minus 2. So we have y is equal to 3 to bracket 0 minus 2. That is 0. 3 times 0, that's 0. Is 0 minus 2. And that is what? -2. So this is -2. You now say when x is equal to 1. So y is equal to 3x minus 2. So it becomes y is equal to 3 into bracket 1 minus 2. So y is equal to 3 minus 2. Y is equal to 1. So this is now what we want to plot. We want to plot the value of x against y. If you now look at this expression, as x is increasing, -2, -1, 0. You know, -1 is bigger or greater than -2. So also is 0 is bigger than -1. Minus means you are owing. This one you are not owing. 0 means you are not owing. 1 means that you have. So -1 is bigger than -2. Is 0 is bigger than -2. I can ask you, which one is bigger? -40 and 0. So 0 is greater than what? -40. Because minus means you are owing. So from what we have now, we have gotten the values of x and the values of what? Y. So we want to plot the graph. Sorry, I want to rub on the board now so that you can see it clearly. So like I said, just pay attention, you are going to get it. Please pay attention. I want to explain something here now, to explain it. So when you are saying that you want to plot graph, in mathematics, plotting of graph is basically this way. Vertical against the horizontal. So this is your vertical line. And this is your what? Your horizontal line. Your horizontal line, your vertical line. In your statistics, you can have it starting from this way, meaning that there is no negative value. When you have this kind of arrangement, it means there is no negative value. But basically in your graph, you must always have this. Even when you are doing your physics, always have in the back of mind that you are going to drop this kind of graph. So this is your vertical. Your vertical is called the y-axis. While the horizontal is called the what? The x-axis. Now I want to bring out something here. Where the point at which the horizontal intersects the vertical, this point is called point 0, or we call it the starting point in physics. This is the starting point. We call it point 0, 0. If I say 0, 0, it means this is 0 for y-axis and it's also 0 for x-axis. And how do I mean? From here now, I can have, and when you are drawing your graph, there must be a constant common difference. If I say a constant common difference, it means that if I have 1, 2, 3, 4, 5, 6, if I ask you now, what is the constant common difference here? It means that if I subtract this, if I subtract 1 from 2, I'm going to get the same value. If I subtract 2 from 3, if I subtract 3 from 4, 4 from 5, the value will always be what? The same. 1, 1, 1, 1, 1. Because 2 minus 1 is 1, 3 minus 2, 1, 4 minus 3, 1, 1, 1, 1. We say the common difference is the same, it's constant. The same thing we apply here, that in your y-axis, the common difference has to be what? Constant. The common difference has to be the same. So meaning that if I put here to be 1, what must follow it must be what? 2, 3, 4, 5. So the distance must be the same. If you check your graph sheet, you see that it's in this format. You have box, box, box. These boxes, they are all graduated. They are all regulated. They are all the same. So what just left for you, by the time you pick your own scale, they call it scale, that's the word. By the time you pick your own scale, your scale must be constant. Not that you put 1 here, you now put 3 here, you now put 4 here, you now put 9 here. No. If it is 2 scale you want to use, that will be 0, 2, 4, 6, 8, 10, 12, 14. Your common difference must be constant as you are picking it. So we now have the 0, 1, 2. So the common difference is 1. So on the negative part, so this is the positive y-axis. The upper part of this 0 point is called the positive y-axis. And this is the what? The negative y-axis. Negative y-axis. This is positive x-axis and this is negative x-axis. So if this is 1, this plane will be minus 1, minus 2, minus 3, minus 4, minus 5. I believe that is clear. So we come back to this place again. We are using a common difference of 1. So this one is 1, 2, 3, 4, 5, 6, 7, 8. So you can say this is minus 1, minus 2, minus 3, minus 4, and so on and so forth. Can you see the way I've graduated the what do you call it? The axis. So now I want to plot the graph. Let me escalate this y part up because we have minus 8 here. And what I've drawn here stopped as what? It stopped at 8. So I can have 4, 5 for y. Then for the negative y-axis, I want to escalate it. Let me extrapolate it down. So if I extend it downwards, I have minus 5, minus 6, minus 7, minus 8, minus 9, minus 10. Now, they said when x is equal to minus 2, we want to plot the graph now. When x is equal to minus 2, y is minus 8. You now come to the graph. When x is equal to minus 2, this is x equals to minus 2. Y is what? Minus 8. This is minus 8. You now have to extend this one out. That where do you think this minus 8 and this minus 2 can meet? This is where they can meet. You extrapolate this one out. Then you extrapolate this one down. So they meet at this point. So this is the point you are going to pick on your graph. Both minus 2 and minus 8, this is their point of meeting. So the next one, when x is equal to minus 1, y is equal to minus 5. When x is equal to minus 1, y is equal to minus 5. So this is minus 5. You extrapolate this one out. You extrapolate this one down. Down. So like this. They have met at this point. The next one, when x is equal to 0, y is minus 2. When x is equal to 0, y is minus 2. So the 0 and minus 2, they are meeting at this point. So 0 and minus 2, they are meeting at that point. So when x is equal to, it will be on minus 2, not 0 points. It's 0 and minus 2. So this one will show that on minus 2, this is what we have on the 0 scale. If you extrapolate 0, it will come to this place. And already we have it to be on minus 2. So they will both meet at this point. When s is equal to 1, y is equal to 1. When s is equal to 1, y is equal to 1. They are both positive. So at this point, this one will extrapolate this one front, extrapolate this one up. So they meet at this point. So you will now join the points together. By the time you join the points together, like this, let me use another marker to join it. You join the points together. You join the points together. You join the point together. If you now look at it, this is what? A straight line. As your x is increasing, as your s is increasing, your y is also increasing. You can see they are both increasing. So this is now what? A line graph, a linear graph, a straight graph. In your other graphs, you may draw it, maybe your graph will form something like this, curve. So this one is what? A quadratic graph, or any other relation that which one is increasing, the other one is reduced. But no problem, by the time we get to that one, I think I will explain that. I think this linear graph is very easy for us to understand. I remain Sir Lumaj. If you have not subscribed, please do so. And meanwhile, our program is far approaching. It's going to start 2024, January, February. Don't miss it. It's going to be televised all over the nation, Nigeria. Please watch out for the pivots. Thank you very much. God bless you. See you later.